Hours by BYK-Gardner. Welcome. My name is John Kowalski. I'm part of the marketing team here, and I'd like to welcome you. Let me get back to the first slide there. This is our office hours. Today we're talking dispersion. If you're unfamiliar with our office hours format, it is a shortened presentation, usually 20-25 minutes-ish, followed by Q&A, discussion. That time is yours. So if you have any questions, any applications or challenges you're facing in your own facilities, just jot them down in the chat box that should be located in the bottom right-hand corner of your screen, and we'll get to them in order following the shortened presentation. Also, we are recording this, and immediately following, you'll receive a link to this recording. Feel free to share it with colleagues, listen later. There's some formulas and some information in here you may want to take some screenshots of. Yeah, with that, well, let's just kick it off. Our speaker today, Mr. Andy Stummer, he's our Director of VMA-Getzmann, USA, Canada, here at BYK-Gardner. He's everything dispersion. So, hey, Andy, how are you, sir?
I'm doing great, John. Thank you for the nice introduction.
Sure.
With that, welcome everybody. What's John? What's the temperature now where you are down in Tennessee?
Gosh, we are 67, if you can believe that. Love it.
Okay, nice.
It's a little bit nippier.
Well, today it's a little bit nippier, but we're definitely headed for spring. So I'm actually calling in from right outside of Washington, D.C.
Okay.
Our office here is in Columbia, Maryland, and I actually live in Frederick, but it's 59 degrees and sunny. Was a little bit warmer yesterday, actually, but we're headed for spring. So
I know. I think everyone's ready.
Yes. So welcome, everybody. Thank you for taking the time to join us today. This is going to be a quick dispersion review. We're just going to talk a little bit about the dispersion process and the different types of dissolvers that we have. But before we get into that, I'd like to just go through a few slides to introduce VMA-Getzmann. VMA is the company that manufactures the dispermats, so the dissolvers. And we have had a strategic relationship here at BYK with VMA for over a good 40 years almost. And what happened was the BYK folks were basically bringing over the dispermats from Europe. There was nobody distributing the dispermats here in the US before that time, and they put them throughout all their lab spaces. And their customers come in to visit the labs, and they were like, wow, these are cool devices. Where can we buy them? And so back then, they all had to bring them in from Europe. So that was when BYK made a strategic decision and negotiated a contract with Mr. Getzmann to actually be the sole distributor of these dispermats here in North America. So since 1988, we actually have the exclusive distribution rights here in the US and Canada. The founder, Herman, is still alive. He's still actively, well, not super actively, but he comes into the office about once a week just to make sure that they still follow his design philosophy. The company is run by his two sons, Christian Getzmann and Martin Getzmann. And globally, they have roughly about 70 employees. Actually, it's a few more now. And they're really all over the world through agents mainly. In Asia, they have a lot of agents, and also in Europe, going through all the different countries. But here in North America, we are their main partner. And they are known to make really high quality products, mainly high-speed dissolvers, or some people call them high-speed mixers, bead mills, basket mills, and a lot of accessories, that you need to operate these dispersers like containers and vacuum systems and those things. They make a really good quality product. Mainly, one of the big differentiators, I have to say, is their motor technology. All the motors that are built in Germany that VMA actually uses for the dissolvers or dispermats are all brushless direct drive motors. And if you ever worked with the high-speed mixer, you would know the advantages. They're super quiet. They have hardly any vibration, and they will last a very, very long time. Basically, there is no maintenance needed, and the shaft goes right into the motor. So there is no, belts or anything like that that have to be replaced or anything greased. So it's really very, very good, solid technology. I've been with BYK going on 20 years, and I've never seen, knock on wood, one single broken motor in the field, which is pretty impressive and speaks volumes for the technology. So again, it's a global company. They are known to make really good products, very innovative. About 60% of everything that VMA actually makes is custom. There's a lot of new end-use markets. Just take, for example, battery and fuel cell. There's a high demand for very specific equipment, and VMA is able to make those machines to fit exactly those needs. For example, like they need nitrogen blanketing through their vacuum systems or argon. So they're able to add these ports and make these units basically functioning parts of these processes. We also have a very cool lab space in Connecticut, in Wallingford, at our sister company, BYK Additives. And then we also have a lab at VMA in Germany, where we can bring people in, customers like yourself with your product, and then actually do a demo run with the equipment and show you how well these machines perform. So let's dive into the dispersion process. And just in a nutshell, what are we actually doing? So when we talk about dispersing, a lot of people think, oh, we're breaking up particles, we're doing all these things. It's actually much simpler than that. When you look at these particle clusters, you see these agglomerates and aggregates. These are basically blocks of different, in this case, we talk about pigments, right? These are particles that are fused together through these invisible binding forces. They are called Van der Waals forces. And all they do is somehow electromagnetically, they're fused together almost like static. And what we're trying to do, we're trying to break up these binding forces and separate these particles. That's really the only thing what we're trying to do here when we disperse. So we're adding shear force by using a dissolver. We have a blade with teeth, and by putting energy onto our disc and the shaft, through the rotation, we're producing the shear forces that actually break free these particles from each other, all the way down to the primary particle size. But for that, we would need to do some sort of media milling, which is a totally different topic, where we use horizontal mills or basket mills with extra beads that allow us to produce even higher shear rates than we get with just a standard blade. And that will allow us then to go from the aggregate level down to the primary particle level. So it's really important to understand that the dispersion process is actually always two parts. It's the pre-dispersion with the blade, and then the fine grinding or the milling when we use the media. Or some people, if you don't want to use media, you could use something like a rotor stator for very low viscous materials that will also allow us to get to super small particles. So remember, it's important that we don't really destroy the particles. That's not the goal here. Of course, there is some destruction that takes place, but it's relatively minimal. But it's really about the breaking of the binding forces that hold these particles together. And again, it's the shear force, right, that allows us to do that. So you want a powerful machine that puts in a lot of energy that allow us then to do that. It's not only about the RPMs, right? People always say, hey, I need a machine with really high RPMs. RPMs are critical because they get us to the right tip speed, but it's really more about the amount of energy that we are putting into our mill base that helps us to get there. And then to round all that off, we want to keep the particles in a suspended state. We need also the right additives so they don't flocculate back together. And our sister company, BYK Additives, has a lot of different choices there. So if you know somebody, they can send you samples. That's no problem. Here is a great slide kind of breaking it down for you. So we talk about pre-dispersion with the blade, where we use a dissolver or a high-speed mixer or a high shear mixer. Some people call them Really important, you can write that down, you need a very high tip speed. And the tip speed that's the optimum window, is between 18 to 25 meters per second. You can calculate it to feet per minute. It's also fine, but we always talk meters per second. It's 18 to 25. And our machines, the higher end models, will actually show you that value on the actual display, so you can see that. When you go then to the second part of the dispersion process, which is the fine grinding or milling, the rotor speed or the milling disc speed runs quite a bit slower. There we're looking at about 10 to 16 meters per second of tip speed. Of course, milling is like a road to Rome. There's many different ways to get there. So we have the vertical bead mills, we have basket mills, and there is horizontal bead mills. And obviously, these are things that we offer. There's other people that use a 3-roll mill, for example, that's not on this slide right here, or other ways, sonification of getting there. But our expertise really is in, the right dissolver selection and the correct milling style or bead mill product. Okay, so when we talk about dispersing, we all start out, we have a slurry, we want to homogenize everything, get everything wetted properly, and then we want to put in the energy. So what we need to watch out for is selecting the right blade, and not only the right blade type, but we also want to make sure that it's correct to the ratio of our vessel. So the rule of thumb is about 1/3 of the ratio of our vessel should be the blade diameter. So if you look at that nice chart here on the right, that shows us exactly kind of like what blade you should be using for various container sizes. And if you look at that chart, let's just say I'm taking a 1 liter, 1000 milliliter vessel, right? You can see there, we can go from a 30 millimeter diameter blade all the way up to a 70. So what you want to do here is want to kind of look at the viscosity of your material. And if you're kind of on the lower end, then you want to reduce the blade diameter, right? So you want to use a smaller blade. So if it's like water, then you may want to start out with a 30 millimeter blade. And if you have peanut butter or something similar, you may want to go all the way up to a 70, right? So that's all possible within a 1000 milliliter container to move in between these different blade diameters. So we really need to dial it in, but ideally we always want to get started with about a 1/3 the diameter of the vessel is optimum. And that would also mean good viscosity. So optimum viscosity when you're dispersing, where you can put in a good amount of energy, is anywhere between 2,000 to 5,000 centipoise, because that would give you also that donut effect, that is that visual cue that will then allow you to actually see what's going on inside of the container, and also allowing you to put in a good amount of energy. Lower is fine also, and more is also okay, but you don't have that nice donut appearing. Here is the formula to calculate the tip speed. You may want to write that down. So it's basically very simple. You take the RPMs of the machine, what you're running, multiply that with the diameter of the dispersing blade in meters, if you want to calculate meters per second. So let's say you're using a 50 millimeter blade, you go by 0.05 times 3.14. That's for pi. And then you would divide everything by 60, right? So that would then give you meters per second. That's the calculation for the tape speed. It's a very important number because that's also critical when you want to go upscale to production. So the tape speed should always be the same, regardless whether you're working in the lab, pilot, or in the production plant, right? So that's a value that should stay the same, because the RPMs on a small lab dissolvers are going to be totally different than you would have on a production scale dissolver, right? Just because the larger blade diameter will make up for the difference in RPM, and you would then be able to reach the same tip speed, even though your RPMs are lower on a production scale unit, because you have a much bigger blade diameter. So that's a very important formula, and you would always need to use it when you're dispersing or even milling. Okay, so this is here the donut effect I was mentioning earlier. It really looks like a donut. You'll see that in a second. So basically, if we put in the right amount of energy, we optimize our tip speed, the viscosity is good, the material flows nicely, then we should be able to see a donut forming inside of the vessel when we look in from the top down. And you can see the dispersing, it actually takes place right there where the edges are of the blade, those teeth that are causing the breakup of these binding forces. You actually would see the same thing on the bottom of the blade. It's just unfortunately not on this picture right here. I forgot to draw it on there, but you would actually have the same effect below the blade, just like you would have on the top. Okay, so beautiful donut right here. You can see it. It looks good. I know if I'm seeing this, I'm doing everything correct. The processing parameters are right. 21 meters per second optimum. And we're good putting in about 850 watts of energy. So that looks really good. I know I'm doing a good job. I'm pre-dispersing. I'm de-agglomerating my larger particle clusters. Now you're going to see something that looks like that some days where you're going to put in 21 meters per second tip speed. You're only adding 320 watts of energy, but the problem here is that your viscosity is very low, right? So basically the donut would automatically collapse as soon as it's formed. So you don't actually see the donut. So I can see that, number one, the way the material flows, but also if you look at the energy input, you have the same tip speed, but only 320 watts of energy. So there's not a lot of resistance. So that means the viscosity is very low. That doesn't mean you're not dispersing, but what it means is maybe you want to change the diameter of your blade, move it up, go down maybe a little bit, or change the formula, right? So that would make it a little bit thicker. That would maybe help putting in more energy, right? If you can't change the formula, then you're fine, but you just have to add more time to the process because it takes you longer to disperse because of the only amount of 320 watts of energy you're putting in versus what we had before, which was, I think, 850, right? So it's probably going to take you two and a half times as long to get the same effect. And then we're going to have situations where you see no donut at all, but you're putting in a good amount of energy. You're still running at 21 meters per second. In this case, your viscosity is very thick, right? So it's a very thick material, like high viscous adhesives, right? Very thick coatings, putties or anything like that. That they don't usually like to flow that much. So you are still dispersing, but basically not seeing a donut at all, right? So you could maybe modify your formula, but not really need it. What I would do in this case, I would maybe change the blade diameter to make it definitely larger to get the product moving, right? If it's very thick, a lot of times it tends to sit around the edges of the container and so on. You may want to use a larger blade to get the product moving. And then what also would be helpful here is maybe get a scraper system that keeps the container walls nicely scraped with what we offer also. So that's a good system for a wall scraper for sure. So here, just a few takeaways, very important. The duration of how long do we disperse, about 15 to 30 minutes on average. You want to have a donut effect ideally, but it's not a must. But what is critical is the tip speed, 18 to 25 meters per second. Anything lower than that, you're not really optimizing. It's much more difficult to get a good dispersion result. Geometric consideration, again, the diameter of our blade. Make sure you start out about a third to the ratio of the container and then work from there up or down depending on your viscosity. And then the right impeller disc also There are many different shapes and styles out there. So find one that actually works well for you and then stick with it. It's sometimes confusing when you actually look at all these different options out there. I don't know if they really all add all that much. I mean, we get excellent results just with our standard blades, but it's available. What's more important, what's not even on here, is actually whether they need to be ceramic or DLC coated or anything like that, because some materials have issues with any type of metal. They can't get in contact with metal, especially like with battery slurs and so on. We offer ceramic or coated discs that are also an option or a choice there. Fill rate about 50%. That's what we're aiming for in the container. Anything more than you're probably going to spill. I mean, you can go up to about 70%. It's still okay, but not any higher than that. Really not recommended. You can go as low as 40% fill rate. That's fine. Don't go any lower, then it makes it a little bit more difficult to oscillate and find the sweet spot inside of the container, right? So try to stick with about 50% fill rate. That's ideal. Pigment filler concentration, obviously, that's your formula, right? And then when we are dispersing, we are putting in energy. Energy means higher temperature increases, right? So we try to keep the temperature in check by cooling. So we recommend always use a double wall container and some sort of chilling capability, especially when you're milling. That's going to be a lot more critical, because milling, we're going to put a lot more energy into our mill base than we do with just a blade. But still, even with the blade, we can see temperatures go up quite a lot, especially when we're dealing with very viscous materials. So keep that in mind. And once we do all that and we make sure we use the right additives and everything looks good, at that point we can move on to the milling process. Just a few options here. Lab dissolvers, what we use here, what we offer is for the lab scale, beautiful, nice machines, very quiet with the direct drive, all the different safety features. Nobody gets hurt when you use the Dispermat, right? The blade is always in the container. You cannot operate a Dispermat with an exposed blade. There are safety features that ensure that you are always safe and no exposed blade or a shaft rotating parts outside of the container. The container clamp is always solidly, locks the container solidly in place, so that doesn't wiggle around. So that's also something that we put into our machines to ensure that they will not run if there is a loose container. The cool part about it, this Dispermat, our dissolver technology, is that they're all exchangeable, right? So you buy a dissolver or a disperser, but you think in a year or two, maybe you want to do some milling with the same machine, and all you have to do is purchase a basket mill or a vertical bead mill or a rotor stator or a vacuum system. So these are all accessories that are available that you can then just add on. You can see right here on this picture, these are different attachments, milling tools or vacuum systems. You just buy them, pop it on, and off you go, and you now have a totally different machine for a different project. So they are future-proof, really, really good for somebody who wants to save money long-term and doesn't want to waste a lot of valuable lab space, because you can buy one machine to take care of all your different projects. Okay, so LC, very simple dissolver, awesome little unit. We have probably 1,000 of these machines right now scattered all over the US. Very, very reliable and relatively inexpensive, but a perfect tool for small jobs. This is our new baby. It's the CB3 Evo. That machine is replacing the old CB3. It's really fantastic. The way that they conceptualized it with all the modular attachments that you can fit on, the CV Evo control panel, it's beautiful, it's haptic, all solidly built. You get all the critical data points on the display. You can look at a graph, actually, real time, showing you all the measurements in real time, like the torque value, the energy input in a trend line, the temperature, so you can see if you head out to lunch and you come back and you want to see, hey, what happened while I was gone? You can see all the trend lines for each of these variables. There is a basic and an advanced model. The advanced model allows you to store all the data on a computer or transfer it to Excel for a lab report. And it also comes with a really cool scale. So you can actually weigh all your raw materials right next to the dissolver and then have all the weight data shown up on the display. So very cool. Everybody that gets the CV3 Evo absolutely loves it. And so do we. Then we have the CN line, which is kind of like our bread and butter instrument for lab to pilot scale applications. Also very nice, very reliable, but the good thing is it's scalable from small to very large models. Also giving you good functionality, all the safety, and all the modularity we talked about earlier. And then we have the C3 control panel, just giving you some basic information. Unfortunately, no tip speed readout, but just basic information, quick and easy and reliable. Then we have the C control panel, what I talked about earlier, that gives you all the important information. That's especially useful for upscaling, right? If you want to go to a pilot scale or manufacturing, then you get all the really important data points here. So that can be very helpful, and the data storing. So that's available for our AE premium line of dispersers. And that's like the CN models. They are scalable as well. So you can go from small lab all the way up to manufacturing, and you'll be able to carry over the data. So the good part here is that our scalability from lab to pilot to production is almost one-to-one. So it's outstanding. So very, very good quality machines for production as well. But we don't have enough time today. But we have presentations that cover strictly the milling component and also all of our manufacturing products that we have that will help you make great products. So thank you so much for joining today.
Yeah, great stuff, Andy, as always. Appreciate it. And like Andy mentioned, we have, a series of webinars like this. I think next month or the month after there's one on dispersion deep dive, and then a similar one on milling. So you kind of get the comprehensive look at this process. If you can't wait till the webinar, there's a link in the chat that leads you to our YouTube page. We keep all of these recordings out there, so you can check out the last one. I think it was just in November. So everything's pretty fresh and new there. If folks have questions, please log them in the chat. If you're experiencing some issues in your own facilities, Andy's here. We have some regional sales managers and another person from Andy's team on as well. So you have a lot of technical expertise here. Just let us know how you can help. While you're thinking about your questions, Andy, I love the modularity of this. I think that is just such a huge benefit, starting off for pilot and then growing as your needs grow. Maybe you can touch on that a little bit more of that value.
Yeah, I mean, I think it's really smart design. Mr. Getzmann should get all the credit for this. Early on, when he designed the first Dispermat, he already had the vision that people want to do more than just mix or disperse, with the one machine. So he actually came up with the idea of putting a quick connect on the Dispermat, and that allows people to very quickly move from one attachment to another, right? So it's like you have an electric screwdriver, right? There's different drill bits and all these other things that you can buy. So it's kind of like the same thing. Much more, solid, of course, because you're dispersing at high speed, but kind of like a very similar philosophy. It's like a bayonet style. So you kind of quickly open a clamping ring, turn the assembly, 90 degrees, and then you pull it out, and then you pop in a basket mill, for example. So
Yes.
The ability for a customer to do all the different projects with one machine is really, really cool. And we see it in our lab. We have customers come in, they want to disperse, they want to work with vacuum, hey, but they want to also do milling. And instead of looking at 3 different pieces of equipment, we just do one thing on the machine. Then the next step, we change out, we add the vacuum system, and then we pop on the vacuum basket mill. And now we are milling on the same machine. So they are always amazed how efficient these machines are. So
Yeah, that
I
quick
think it's a
connect,
big product. Yeah.
that quick change clamp really helps because it keeps the equipment operational, and that's how you're making money. Also the cleanup too. It's really streamlined, and it's a fraction of the time compared to other systems. Maybe can you give us some stories from the field on cleaning time and running time?
Cleaning, I would say yes and no. I mean, I don't want to just take all the credit for our equipment on that. It really depends a lot on the person, how efficient they are. But I have to say, if you have one piece of equipment rather than multiple pieces, you obviously have already one big advantage there. And the way that you're able to easily remove the tools from the disperser, and you put them over to a sonic bath, for example, or if you look at our basket mill design, you can see there are some key advantages there. But I mean, obviously, cleaning is always a sore spot for a lot of people. And with our equipment, we try to make it as easy as possible. But that's something that you would see for yourself when you come to the lab, how easy and how efficient you can clean with that equipment. So
Great. Are there again, if you have any questions, please log them in. Quiet group today. If my question for you, Andy, I just lost it. Oh, there we go. When you're first talking to customers about their dispersion needs, kind of what are the key things that someone needs to kind of get in line, that will help you evaluate what types of systems and how to optimize their current system?
Yeah, so the first thing before we want to sell a piece of equipment, for us, it's important to understand what the customer is doing, right? And what are actually the problem areas? What is he trying to solve? So very important for us is one of the first questions: what material are you trying to disperse or mill? What's the final particle size? That what kind of puts us already on a path that we know, okay, we can use a basket mill for this approach. We can use a horizontal bead mill. Maybe he only wants to work in the lab. Maybe an APS bead mill is the better choice there, So it really depends a lot on what the customer is trying to do. Excuse me, are they trying to upscale? If they want to work with the same technology platform in manufacturing eventually, then that limits the choices somewhat to a basket mill and a horizontal bead mill. So just finding out exactly what the end goal is and what material we're dealing with. Is a vacuum required? Is air a problem? What are some of the challenges that the customer is facing? What's the viscosity like for a scraper system? Do we need that, or can we stay away from a scraper? So, excuse me, I have a very, no, it's a cough. I have a dry throat. Sorry.
Need some water? I can talk and ramble.
I'm fine for a few more minutes. So thank you.
No, you talked about the importance of the equation and the tip speed and getting the numbers right. Are there common issues you see that are people are doing out in the field that are just need a couple tweaks to kind of get on track? If so, do you want to share them with the audience?
Well, I think most people, that use that technology are already pretty familiar of how to use a dissolver, and they know their product better than anybody else. What they really benefit from understanding, kind of like some of these accessories and how they can help them improve maybe a process. They have a lot of questions about media selection for beads. What should be used there? What would like some of these different blade shapes and so on, what they can do for the customer. But
Mhm.
I think we see sometimes, I mean, not everybody is always super advanced, and it's always a function of money, right? Everybody
Mhm.
that has a lot of money can obviously buy all the greatest and best and latest equipment, but that's not really the case. So we see, and we, believe it or not, see customers that still run on drill presses and try to disperse with the drill press, from Home Depot, and just put a blade on there.
Yeah.
I mean, it works, but the problem is you have no safety, and there are so many other issues. If you want to scale or you want to, compare it to other projects, you don't have all the critical data points that you want. So, yeah, maybe helping those people understanding the value of better equipment. But I think staying safe is just as important.
Yeah.
And I would say our diplomats are super safe. Like all the design around them, we have redundancy even in the control panel itself. Like there is something called a Dispersafe. It's basically a safety relay, a module that is purpose built for the Dispermat that will ensure that all the values that you're putting in, if you have threshold cutoff values, for example, for temperature, or if you're running with constant speed, you can have a power cutoff point. And all these things are always cross-checked through the Dispersafe module so that there is always the assurance that all the data is correct and that nothing funky is going to happen here,
Hmm.
where the machine will shut off. And all the other safety features, like I explained earlier, with that container clamping system or the right height adjustment or height setting in the container, we call that the reference setting. So you have H1 and H2, allowing you then to operate the disperser in between these two reference points in the container. So if the machine is running, let's say 20,000 RPMs, and you were to push the up button and you are raising up the shaft, it would automatically stop at the highest point so
Hmm.
that the blade would not come out of the container at 20,000 RPM, right? I mean,
Yeah.
that could do
Yeah.
some serious damage. It cuts your
Yeah.
finger right off,
Yeah. Definitely.
So we make sure that we have these safety features in place.
That's great. I mean, during your presentation too, you mentioned, I think, inks, coatings, paints, adhesives. Um, what other markets can this play in? Would that include food applications in pharma,
Yes,
cosmetics?
yeah. I mean, cosmetics is big, nail
Yeah.
polish, all these different products that people put in their face. If they have, liquid form or paste form, these
Hmm.
formats are used for that. Any type of, uh, lotions, pharmacy products. We have FDA grade materials. We can get certificates. So that's definitely available. I will always reference, there's other end use markets like the battery arena is
Mm.
really a hot topic for us right now, as it
Yeah.
is for everybody else in that space. It's booming like crazy. There's a lot of money, and people really spend to get the best possible equipment to process these slurries, the
Yeah.
anode, cathode, and the barrier coatings that go into batteries. Fuel cell is very big also. 3D print media,
Ah,
agro science, for example, is another big one, all the
all over the
different,
place.
yeah, it's really everything liquid, and you're adding something and you try to homogenize it or disperse. So that's where you wouldn't find of all of our equipment.
Got a question from Mike here. He's asking, you mentioned the headquarters, our headquarters, Columbia, Maryland. What does our service look like? Can we do in-field service? Do we, cover all of North America, US and Canada?
So, great question. Our service team is trained on all the equipment. We have very capable folks that are basically going across North America to all the different locations on a whim. If a customer has a problem, we'll be there. We have also excellent phone support. A lot of things can be really solved, but just doing a reset or going, talking to one of us. But if somebody needs to come on site, that's no problem. It can be turned around very quickly within 24 hours. And then what we do for production scale, we always offer a spare parts package. We actually won't sell you a production scale Dispermat unless a spare parts package is included. And these are just basic wear items, right? I mean, of course, if you're producing and the motor goes down, which we haven't never seen yet, but of course that will take some time to get. But that would be with anybody else, right? If you have a big machine and the motor dies, and it's not going to happen overnight. So always have a contingency plan also in place. Don't rely only on us as a supplier. Have also, if that's a critical piece of equipment and the livelihood of a company depends on it, then don't just buy one machine, have a backup, or something similar that you can fall back on if the workhorse, dies on you. I mean, that's the smart approach here.
Yeah. Got a question here from James about the time using our Dispermat products versus like a 3-roll mill. In time in milling the equipment or milling the material. Do you have any statistics or guidelines? When
I mean, it depends on products. I mean, we have, because lately, we get a lot of calls from customers and lab visits that want to move away from 3-roll milling. Number one, 3-roll milling is very time consuming. 3-roll mills do an excellent job of really getting the particle size down, but they take a long time. But the biggest problem there is also safety, right? So 3-roll mills are not really safe to use. But we have customers. Just last year, we had a big project, and we had a guy come in. It was actually a company southeast, and they brought in 2 or 3, I think, 2 different colors. It was a maroon and it was a blue, I think. Yeah, it was a blue. And they were telling us that they were work on 3-roll milling these materials for about 14 hours. One was 14, one was 18 hours. I don't remember exactly which one. And they came in to look at basket mills. And they were already booking their plane tickets and thinking, we're going to be 2 days, 3 days in the lab making this material.
Yeah.
Well, by noon on the first day, they were already back to the airport. The maroon took 1 hour and 20 minutes to make, and the blue was done in 1 hour and 15 minutes.
Wow.
So they couldn't believe it, how quickly. And that was for a dispersion for a coatings application. So that took really hardly any time at all to get it down to that. It was a Hegman. We went down a Hegman of 1, or what was very, very, no, sorry, 8 Hegman, not 1. So very, very fine dispersion. So great results there.
Yeah, that's a huge, 14, 18 hours versus what, an hour and a half? Huge.
Yeah. No, they couldn't believe it. And we got a big order out of it. So, and they're still happy. So they're running and save them a lot of time and money.
Right, exactly. Keep pumping that product through.
But the funny part was just to say when the guy, because there were 2 people, and the boss sent them in to look at the technology, and the operations guy who had to come on this trip was not convinced that the basket mill would actually be able to do it, So he was not the happiest guy in the morning. And when he saw the results, he became our best friends.
Oh, that's a great story. Love that. Love that. I think just, another question. I know we have, you can configure these to all different electrical, what if some area has kind of a funky electrical code? We can work with the local municipalities and make sure we adhere to all those. Yeah.
Well, we don't work with the municipalities. That's up to the buyer of the equipment. But what we do
Okay.
normally is we definitely validate and check to make sure that you have the right power available to run these machines. So
Mm-hmm.
all the smaller dissolvers go on 110 or 230 volts, single phase. Production scale, we need 480 or 440. That's standard, right? Some people have 233 phase or 28, so we can work with all those. We just got to know from you, hey, that's the power we have in the building,
Mm-hmm.
and the Dispermat work with that, and then we'll put together the quote, and then we will spec it out to meet your electrical requirements there. So
Perfect. Any other questions out there, folks? We have a few minutes left, but if nobody has any questions, we won't hold you. I know everyone's busy. Yeah, keep in mind, as soon as we close this out, you'll get an automated link to this recording. If at any time you have any questions, you can simply hit reply to any of the marketing messages you get. It'll come to me or my team, and we'll funnel it to Andy and his team of technical experts, and they can get that question answered to you or answered for you. Also, Andy mentioned the Dispersion Lab in Wallingford, Connecticut. That is available to you if you would like to run trials, see what your material looks like on our equipment and kind of kick the tires. We also have that it's actually in the facility of our sister company, BYK-Me or BIC Chemical. They help with the additives, so they're available as well to look at any of the materials, and they can offer their assistance. It's also used for training. Andy can put on a day-long dispersion and milling seminar if that's something you or your facility or folks need too. So we're very flexible here on this end. And like I said, just hit reply to any of the marketing messages or visit dispermat.com for additional information about the instruments, as well as we have a knowledge library section full of a lot of articles. We're adding to that. It seems like every couple of weeks we're tossing up a new article. So take a look there, visit that. And with that, I think we'll wrap up here. Andy, thank you as always. Always a pleasure hearing from you, and I always learn a couple new things every time I listen. So thanks for joining us and sharing your expertise.
thank you, and appreciate everybody being on today. Reach out if you have any more questions.
Yeah, have a great day everyone. Thank you for joining us, and we look forward to seeing you on future BYK-Gardner web seminars. Thank you.